In this segment, we're going to just start off by looking at what is a polynomial function and what isn't a polynomial function, and then talk about some ways we describe them. Polynomial function, I'm going to use p of x for polynomial. It doesn't matter, it could be f of x. Has this form here. It's a really kind of ugly looking definition. A sub n, x to the n, a sub n minus 1, x to the n plus n minus 1, plus a sub n minus 2, x to the n minus 2, etc. until we get down to a sub 1, x, of course, to the first, plus a sub 0, and technically we do have an x to the 0 there, but that's 1, so we usually don't write it. The conditions are that the a's in front, those coefficients, are all real numbers, any kind. They can be decimals, fractions, roots, anything we want them to be. So they're any kind of real numbers. But n, the exponent here, has to be a non-negative integer. And if this is a non-negative integer, then since we're just subtracting 1, 2, 3 all the way down, okay, the rest of them are going to be non-negative integers as well. Let's take a look at some examples. All right, I've got four functions here. 3 of them are polynomials and 1 is not. The first one is 7x to the fourth minus 3x cubed plus 8x minus 5. I'm not too concerned that I'm missing the x squared term here. That's not part of the definition that you have to have every single one. So this does qualify. All the coefficients there are real numbers. The exponents are nice normal integer numbers. If I want to know the degree of a polynomial, I'm going to look for the term that has the highest exponent. In this case, it's this first term here. So this leading term here has a leading coefficient, the number part, of 7, and the exponent is the degree, so it's a degree 4. That's also sometimes referred to as a quartic, not quadratic, quartic. Right, this next one, it's out of order, but the definition doesn't say it has to be always written in order. So my coefficients, the number parts, they're all real numbers. My exponents, both non-negative integers, so this qualifies as a polynomial, and this time my highest degree term is actually in the middle, and that means my degree for the polynomial is going to be 3. The third example here is actually not going to be a polynomial, and the reason is this last term. 4 over x, well, you're saying what's wrong with x to the first, but it's not really x to the first, because when you have a variable in the denominator, or actually anything in the denominator, it's equivalent to having a negative exponent on it. So 4 over x is really equivalent to 4 times x to the negative 1. So this last term disqualifies the third example from being a polynomial. The last example, my coefficients, the numeric part, those are fractions, but that's okay. We don't care about the number part. I look at my exponents. Those are both normal non-negative integers, so this would qualify as a polynomial. Our highest degree term is going to be this first one here, so my degree is going to be a 3. We sometimes call that a cubic.